So hey guys, today is pretty simple. We are going to go over systems of equations, more specifically linears, and only will be going over the substitution method instead of the um, elimination. So only substitution. So the basis of substitution is pretty simple. So for example, you have an apple of $50, okay, and a person, so a man, has $50. So since $50 is equal to $50, we can say that the man can buy the apple. This is the principle of substitution in that if one thing is equal to something else and another thing, that exact same thing, is equal to another thing, then this must equal to that, okay? And that is the basis for substitution. So let's take a look at a direct example. So for example, we have the first equation is 4x plus y is equal to 24. And let's see, y is equal to 3x plus 18. In this case, we can see that here they're saying that y is equal to something, and in the first equation we can see that we have a y. So we can say that since y is equal to 3x plus 18, we can put the 3x plus 18 into the place of y. Our goal when we have a system like this is to get rid of one variable. So in this case, if we substitute 3x plus 18 into the y, because again, y must equal to y, therefore this must equal to that y, right? So in this case, from the two equations, we can get one equation. So namely, we can say 4x plus y is the same thing as 4x plus 3x plus 18. And that equals to 24. Okay, remember that this part right here was a y. Okay, so in this case, from there we can go 7x plus 18 is equal to 24. So we can solve for x by saying minus 18. Okay, so then we get 7x is equal to 6, and then divided by 7, x is then equal to 6 over 7. Okay, so once we know what x is, we can substitute it back into any of the two original equations, that one or this one, to find what y is. Because remember, our goal is not just to find x, but to find y as well. So we can say 4, since x is equal to 6 over 7, we can just go ahead and take x and put it into the place of an x that we see in the equation. So we can say that is 4 times 6 over 7 plus y is equal to 24. Okay? So in here we can get that there's 24 over 7 plus y is equal to 24. So to find y, we subtract 24 over 7 on this side, minus 24 over 7. We can say y is equal to 24 minus 24 over 7. And of course we can do that by finding a common denominator. So then we get y is equal to 24 times 7 over 7 minus 24 over 7. 24 times 7 is 168 over 7 minus 24 over 7. Okay, and then we get that it is 144 over 7. Okay, and so we can leave y as 144 over 7, or we can reduce that as well to so we can say 20 would give us 140, and we have 4 left over 7. So we want to reduce that. Okay, so that's what y would equal. So that is our goal when we have a system of equation like this, is to solve for x and then solve for y, or solve for y and then solve for x. Okay, let's take a look at another example. So let's say you have the first equation is y is equal to 3x plus 18. And then we have another equation, y is equal to 36 plus 9x. So unlike the previous problems, what we have is that in this case, this equation, y is equal to a blob, and then this y is equal to another blob. And logically, like I said before, if an apple equals to $50 and a man has $50, therefore a man can buy the apple, or the man is equal to the apple. So in this case, we're going to say y is equal to something and another y equal to another thing. So we can say 3x plus 18 must equal to that green blob, which is 36 plus 9x. So as you can see here, once we do that, we don't have a y variable anymore. All we have is the x's. And from there on, the problem should be pretty simple to solve. We just solve for x, so minus 3x. Minus 3x. We get that is 18 equal to 36 minus 6x. Minus 36 minus 36. We get that it is 18 equal to negative 6x divided by negative 6 divided by negative 6. We get x is equal to negative 3, right? So if x is equal to negative 3, remember that when we have a system like this, we have to solve for y as well. So substitute x, which is negative 3, back into any one of these equations. We don't have to do both. We can to double check, but we don't have to. So we just pick y, I'll just pick the first one, is equal to 3 times negative 3 plus 18. Y would then be equal to negative 9 plus 18. Y is equal to 9. Okay, so the solution for this is negative 3 and 9. What it means really is that when we have a system like this, is that when you graph the equation, we get, let's say for example, that's the 3x plus 18. Remember, this is just an example. It's not really the accurate one because the scaling will be a little bit different. And we get that is 9x plus 36. So really what we're looking for when we have a system like this is, system of equation is where do the graph intersect. In this case, of course, we will get an intersection, which is a coordinate. Okay? And remember, this is just an example. It's not representative of this problem. Okay? So whenever you have two lines, the first line, the second line, we always want to find an intersection. An intersection will always be a coordinate, and a coordinate will always have two points, x coordinate and y coordinate. And in this case, remember, we're not done when we solve for x only. We'll also need to solve for y. Okay? So remember, the principle of substitution is pretty standard. Not difficult at all, in that if something is equal to a value and another thing equal to another value, and they're equal to each other, then we can set them, we can replace them or substitute them into the place of the equation. Okay, so that is pretty much it for system of equation for substitution.